Okay guys, how are you doing? This is a small class, I guess that I could say I'm able to do right now. So what I'm going to teach you is like how Pythagoras theorem, yes, theorem is incomplete. Yeah, you heard me. Pythagoras theorem is absolutely incomplete, absolutely utter phony. What we've learned, and let me show you first. Okay, so what we learned in school is that Pythagoras theorem's equation is a squared equals b squared plus 2a plus c. A squared plus b squared equals a squared. A squared equals b squared plus c squared. That is what we learned in school, and yes, that does imply to many things, but one thing we have looked at also is one of its rules where if you're using this at an angle, that angle must absolutely be 90 degrees no matter what. The angle to its the side to its opposite must be A, and the sides around it 90-degree angle must be B and C. Doesn't matter which is B, which is C. This is what we learned in school, and this is what we learned in first grade. Now let me show you something else. We also learned something called the cosine rule, and we obviously know what this is. This applies to any two sides and an angle between them. So we'd say a squared equals b squared plus c squared minus 2bc cos x. That is what we've learned before. Let me just fix the x. Sorry about that. It's my first time using something like this. Cos x. That is what we've learned, and we've known that a squared is, sorry, not a, let me just draw this out for you. This implies when there are two lines, the angle between them will be x, the lines on either side will be b and c, and if there is an adjoining line, we'll call that a. Now, doesn't this look familiar? Yes, it does. What we do here is like the chosen angle, which is x over here, can be any chosen angle with x over here, doesn't matter what, but what matters is that a will be absolutely opposite to the chosen angle. Same case with Pythagoras theorem. So in Pythagoras theorem, we obviously remember, I'm not going to write the equation again, I'm just going to draw this line. This is 90, a, b, and c. B and c don't matter, they can switch between them. Now this 90-degree angle, let's consider this whole 90-degree angle. We've already done that. Okay, let me fix myself. This 90-degree angle, let's take it as x. Yeah, x equals to 90 degrees. So why don't we put it into the cosine rule? Yeah, so if we actually put it into the cosine rule, just the angle, so that would mean, so what we have is, sorry, a squared equals b squared plus c squared minus 2bc cos x. Now what if we put this x right here? We put the value of 90 degree right here. We forget the values of this thing. We just need to put the value of x right here. So what we do is we put in cos 90, and so it's okay if you don't know this rule, but cos 90 is always equal to 0, no matter what, always equal to 0. So what this means is that if we put, let's say, I'll just take this small part, 2bc cos 90. If we do this, this would give me 0. So 0 multiplied by that 0 will always be 0. So what will be left? Well, let's write this equation one more time. A squared equals b squared plus, this is how you know you're bad at math, you keep messing stuff up, minus 2bc whatever. If this whole thing is equal to 0, nothing, we will be left only with a squared equals b squared plus c squared, which is Pythagoras theorem. Now you guys understand what I'm trying to tell you? Now what I'm trying to say is that if you put 90 degree into cosine rule, you will be given Pythagoras theorem. Now this might not exactly register in your head even after all this explaining. I understand that because my board isn't so big, so I keep erasing my stuff. But if you, I don't know, if you have the patience to rewatch the video a couple of times, you might actually get it. And if you don't, and if you're still curious, you might, you can actually come up to me or even go up to Mr. Amin and ask him like how Abrar did it. If you're curious, if you think that this is very time consuming and doesn't really explain a lot, it's absolutely fine. We don't need to know this in AS, but this is just something that I've stumbled upon and something that books don't teach you. But then again, that doesn't necessarily mean that this is very, very important. This is not that important. It just says that. So in conclusion, Pythagoras theorem is actually cosine rule. So let's see. Let's write it in a better way. So let's say cosine rule. If in cosine rule we put in 90 degrees, 90 degrees, we will have an output of Pythagoras theorem. And if you guys want to really solve this on your own and figure this out on your own, I'll just write down the whole function of how this works. Very simple function. And if you guys still don't get it and still don't want to get it, absolutely fine. Again, I'm not forcing you into learning this thing, but this is something that I really want to share about. Okay, so we have so let's say we have our cosine rule, which is a squared equals b squared plus c squared minus 2 bc cos x. Now if x equals 90, find equation